Hello friends. Now in today's video, what we'll be doing is we'll be continuing the practice problems for conditional statements. So now in this problem, you have to find that whether any character entered by the user is a letter, small, lowercase letter, uppercase letter, digits, or it is a special character. Now you know that whatsoever you entered, whether it is plus, whether you are entering minus, whether you are saying 1, whether you are saying 2, whether you are saying A, B, etc., or underscore, they are not taken by the computer as such. A code is assigned or attached with each and every character you entered through a keyboard. And that is basically an ASCII code. So let me show this to you. Let's say you wanted to know what is the ASCII code associated with character A. Oh, character A. So if you run this, you will be able to see 65 is the ASCII code attached to A. Now let's say small a. So it is having an ASCII code of 97. Let's say this character minus, which you say, now this is having 45. Let's say plus, so this is having 43, and so on. So each and every character which you enter through a keyboard is having an ASCII code attached to it. So to check whether a number or a character entered by the user is uppercase, lowercase, digit or special symbols, what you can do is you can check whether the ASCII code of the number entered by the user is um, 65 from 65 to 90, whether it is from 97 to 122, okay, or whether it is 48 to 90, 57, or if this is lying between this 65 to 90, then it is uppercase. From 97 to 122 it is lowercase. From 48 to 57 it is numbers from 0 to 9, else this will be a special symbol. So the problem will be if this A, if the character, let's say CHAR is the character entered by the user. So if this CHAR is is more than or equal to 65, and this is also more than or equal to 90, then that is uppercase. Else if this range 97 to 122, lowercase. Else if it is from 48 to 57, else if then it is numbers or digits. If neither this nor this nor this, then that simply means the remaining will be a special symbol or symbol. So let us write a code for it. So let's say CHAR, no, so we cannot use a keyword as we cannot use, remember, we cannot write a variable name as your as a name which has already been reserved for either keywords or function names. So we should be very much cautious. So we can still use char by changing the lowercase to uppercase. So CHAR, let's say this is the character entered by the user. So let us enter it. Let us ask the user to enter this. So enter enter the character, and then scanf. This is character, so the format specifier is %C, and then at the address of char. Okay, now if the character entered by the user is more than or equal to, if the character entered by the user is more than equal to 65 and character is less than or equal to 90, then what can we say? We can say that it is a uppercase. Okay, now uppercase letter like this, 65 to 90 uppercase O. Else if the character entered by the user is 97 to 122, so if it is 97 to 122, then it will be a lowercase. Else if neither this nor this, and then again you have to check whether the character entered by the user is lying between 48 to 57. So if it is if the character is more than or equal to 48 and this character is less than or equal to 57, again check 57, then this will be what? Digit. Okay. If none of the condition entered here is valid, then simply say that it is a special symbol. Okay. Now let us run this program and see what happens. So enter the character, or should we enter a character? Okay, doesn't matter. Enter a character. Let's say I have entered A. Now you know that this is a lowercase, so it is a lowercase. Let's enter another one. Let's say I entered 5 this time. So this is a digit. So it is a digit. Okay. Now again run it. Let's say I entered capital S. So this is what? Uppercase. Okay. Again run it. Let's say this time I entered multiplication. So this is special symbol. So in this way, you can write a program with the help of ASCII codes for the characters to know that whether a character is a lowercase, uppercase, a digit, or a special symbol. So you should remember this table, at least for upper, lower, and digits. You should know that what is the range in which these numbers or these characters are falling. So let us come to the last problem for this series, for this basically topic. So it is saying that given three numbers, so three numbers are given to you, 3 points basically, and you have to write a program to check if all the 3 points falls on one straight line. So if this is my coordinate system, x and y, let's say I take any two out of them. Let's say I take x1 and x1, y1. This is 1 point. Another point I take x2 and y2. Now I join these 2 points. So what will be the coordinate of any point which is falling on this? So if this is x, this is y. So equation of a line passing through 2 points, 1 and 2. So what is that? So that is y is equal to y1 plus y2 minus y1 by x2 minus x1 into x minus x1. Okay, so this x and y are on this particular line. So if I wanted to check that whether a point x3 comma y3 is also lying on this line or not, then what you can do is you can simply replace x3 here in place of x. So it becomes y is equal to y1 plus y2 minus y1 by x2 minus x1 into x3 minus x1. And if this y comes out to be equal to this y3, that means if y becomes equal to y3, then all the points are in a line. If this is true, then all the points will be in a line, else not. Got the point? So in this way, you can check whether 3 points given by user are in a line or not. So what we have used simple Cartesian coordinates knowledge, that is equation of a line which is passing through 2 points, and then setting up supplying the value of x3 to that particular line and checking whether the y which we are getting now is equal to y3 or not. That's it. So let us write a program for it. So let's say I want to enter the coordinates. So now let first x1, y1, then x2, y2, x3, y3. Now these are the points, and as well as that y. Now printf enter the coordinates x1, y1, and then new line scanf percentage d, percentage f, and this is your x1 at the address of x1, at the address of y1. Okay, and this will be doing for all the coordinates. So this will make the program much clear that what we are doing every time. You can give everything in a line, but that will make the statement clumsy. So by doing this, you will be making the program more readable. So x3, y3, and this is x3 and y3. Okay, now what next? So if you look, now you are having all the coordinates. So the task is to evaluate this y. So y is equal to y1 plus, now y2 minus y1 by x2 minus x1, and this whole multiplied by x minus x1. So I'll do it here into x. Now x is replaced by x3, so x3 minus x1. Look again. So it is y2 minus y1 into upon x2 minus x1 into x3 minus x1. So y2 minus y1, x2 minus x1, x3 minus x1, and this whole is added to y1. Okay. Now you will be checking if the y comes out to be equal to this y3, then you can say that printf all the points are falling on a line. If it is not equal, then that simply means printf the points are not falling on a line. That's it. So here this is the so that's it. That is how you can write this particular program. Let us run it and see what happens. So let us enter the first coordinate. So let me pass first the coordinates where all the points will be falling on a line. So let the coordinates be 1, 1, 2, 2, and 3, 3. So 1, 1. Another coordinate 2, 2. Another coordinate 3 and 3. So all the points are falling on a line. They should fall because if you look this, so this is a line y is equal to mx, which is passing through origin, and this m comes out to be equal to 1, so y becomes equal to x. So this is y is equal to x. So when x is equal to 1, this y is also going to be 1. When x is equal to 2, this y is going to be 2. When x is equal to 3, this y is also going to be 3. So that's why they all are lying on this line. So let us take another example where one coordinate is 1, 1, the second one is 2, 2, and the third one is 3, 4, not 3, 3. Then what happened? It should not fall. The fourth point should be here. Okay, so let us check it with the help of the program developed. So the first point is 1, 1. The second coordinate is 2, 2. And the third is 3. Not 3 this time, I will be keeping 4. So the points are not falling on a line. So in this way, you can check whether 3 coordinate points given to you are falling on a line or not. And this brings to end the topic, that is conditional statements. Now we have solved ample amount of problems to understand the topic in greater depth. So in this video, till this point only, thank you very much for watching it.